Hi, welcome to the video solution guide for problem number 4 from the 6th problem set. In this problem we have an individual with a mass of 60 kilograms and they're running in a circular path, and the circular path has a radius equal to 25 meters, and again the mass of this person is equal to 50 kilograms, and they're running with a constant angular velocity that's equal to 0.25 radians per second. So that's the angular velocity, and that's constant. And we're asked to find the tangential and radial forces being applied to this individual as they complete this turn. So we can use our Newton's second law, which is F equals the mass times the acceleration, to find these tangential and radial forces. So let's start with the tangential. So the tangential force is going to equal mass times the acceleration in tangential direction, which is going to equal the radius times the angular acceleration. Because this individual is running at a constant angular velocity, the angular acceleration is 0, so the tangential force will also be 0. We can solve the radial force being applied to this individual in a similar approach. So we have the mass of the individual times the radial acceleration, which is going to equal the mass times the radius times the angular velocity squared. And we know all of these variables, so we have 50 kilograms times the radius, which is 25 meters, times the angular velocity of 0.25, I keep wanting to say meters per second, but it's radians per second, and that quantity is squared. When we calculate this, we find that the radial force being applied is equal to 78.125 newtons. And this is our solution to the problem. Pretty simple.